The second law of thermodynamics is sometimes called the law of increasing disorder. What it basically says is that as things happen in the world, processes, mechanical processes take place, the total disorder of the universe increases. Now you can think of different kinds of energy as having different degrees of order and disorder. For example, if you have an object that moves like this propeller, it's said to have macroscopic kinetic energy. It's the energy of a macroscopic visible object, all the molecules kind of moving together doing the same thing. That's a very ordered form of energy. The most disordered form of energy is the random motion of molecules. For example, if you have water in this container, those molecules are moving in a completely random fashion. Insofar as these molecules all have the same average kinetic energy, that is to say, the molecules are all characterized by the same temperature, that state is the most disordered form of energy. Whenever you see molecules that have temperature differences, then you see a residual amount of order still in that random motion of the molecules. For example, we have some cold water here and some hot water here, and that difference in temperature represents a certain amount of order still remaining in the random motion of the molecules in those two containers of water. Now, the second law of thermodynamics, or law of increasing disorder, says that if you want to take energy of one kind and create a more ordered kind of energy from it, for example, take disordered energy in the molecules and create this very ordered form of macroscopic kinetic energy, then whenever you do that, at the same time, somewhere, there must be some disordering going on in order to increase the total disorder of the universe. So if you try to extract energy from molecules in order to turn it into this ordered form of energy, the device will not work as long as you try to extract it from random motion of molecules all at the same temperature. Even if you take this object and plunge it into this very hot water, where you know that the molecules have a great deal of energy, the device still will not work. It will not take this disordered form of energy and create it into the ordered form of the macroscopic kinetic energy. And the reason it can't do it is because it has no mechanism left to increase the disorder of the universe. It's looking at energy that is already very disordered, and at the same temperature throughout, there's no way of increasing that disorder. Now, this device, nevertheless, can work and can create the macroscopic kinetic energy of the propeller. But it must have a source of energy in which there is some residual order. And some of that order must be disordered at the same time that some of the energy is being ordered to create the macroscopic kinetic energy. So this device works when you take the cold water and the hot water and move them together and put the device into it in such a way that it sees this difference in temperature between the cold and the hot. That represents for the device a certain amount of order. And it's from this order that the device will increase the disorder of the universe, while at the same time creating the ordered form of macroscopic kinetic energy that represents the whirling of the propeller.